All right, hey Honors Chemistry. I just wanted to post a brief video of something that we talked about on Thursday about how we use these factors to figure out the relationships between pressure, volume, and temperature. So I'm doing question number 1 on your worksheet. It says, what would be the new pressure? So I'm looking for a new pressure. What would be the new pressure if 250 centimeters cubed of a gas at standard pressure is compressed to a volume of 150 centimeters cubed? Okay? Now remember, we have standard temperature and pressure. I call that STP. At standard temperature and pressure, that is 1 atmosphere and 0 degrees Celsius. Okay? So it's looking for a new pressure, and it's starting at standard pressure. So my standard pressure is 1 atmosphere. Now remember, there was this table on your worksheet that looks like this. We have initial, final, and effect. And this is just so you understand how to organize your thoughts into a table. So things that we could look at that could be changing: P, V, T, and N. Okay? Now with this table, we have to think about what is changing and what's not changing. Well, in this question, it only gave us a pressure and a volume, and it didn't talk about temperature, and it didn't talk about number of particles. And remember, N is just number of particles in a container. So temperature and number of particles were not mentioned at all in this question. We're going to assume that it's constant, so I don't even look at that part of the table. All right, so I'll say not applicable or available. Okay, and so now what I'm going to try and do is look at what was given to me as far as pressure and volume. Well, if I reread the question again, sometimes some of us don't like to reread, or it's too much to read again, but it says, what would be the new pressure, so I'm looking for a pressure, if 250 centimeters cubed of a gas at standard pressure is compressed to a volume of 150 centimeters cubed. So my initial volume must be 250. This must be my initial volume, because it's what I start with. So I'm going to put that over here as my initial volume, 250 centimeters cubed. Okay? And it was originally at standard pressure, which is 1 atmosphere. So I'm going to use 1 atmosphere. It tells me that my volume is compressed or contracted, compressed to be smaller. So if my volume is compressed, my new volume was 150 centimeters cubed. Okay? What happened to volume? The effect is just saying what happened or what is going to happen. So for my volume decreased. So I'm putting it down here. My volume decreased. If I know the relationship between pressure and volume, if I decrease my volume, what has to happen to my pressure? Well, you should know that pressure and volume are inversely proportional. So if I decrease one, the other must increase. So I know that I need to have a pressure that increases. And from our notes from Thursday, we have this idea of a factor that I need to multiply by my pressure to get my new pressure. A factor is going to either be a small number over a large number, or a large number over a small number. Now, if I multiply by a small number over a large number, I'm going to get a smaller number. If I multiply by large number over a smaller number, I'm going to get a larger number. And refer back to our notes about this whole larger and smaller numbers and what this factor is. Remember, pressure and volume are related, and they're inversely related. So I could figure out with my factor, whatever I do to one, I have to do to the other. So I can figure out whether I need to go smaller or larger in this sense. Well, I already figured out that my pressure must increase or become larger because volume decreases. And if you remember the graph of pressure versus volume, it looked like this curved graph. This means it was inversely proportional. So whenever I do the one, I do the opposite to the other. So I could start setting up my calculation. And remember, the in general calculation is given initial times some factor is equal to my new final. Right? I kind of changed the wording. I said like given quantity before, but I'll say like an initial value times by some factor to get a final value. Okay? So if I start setting this up, my given initial for this problem that I'm trying to find is my P. So I'm going to have my P initial times by some factor, whatever it may be, and I'm going to get my P final. And the way that I could check my work is if my final pressure is higher, I did this correctly. So my initial pressure is 1 atmosphere, and now I'm trying to set up my factor. Now, I want my pressure to increase. So do I use small number over large number, or do I use large number over small number? I want to use a factor that gives me a larger pressure, so I must use large number over small number. And now what goes in my factor, and that goes back to our notes on units, I'm comparing pressure and volume. So I'm comparing pressure and volume. So in this factor needs to go my two volumes, centimeters cubed, centimeters cubed. And I've already decided that I want to put the larger centimeters cubed on top and the smaller centimeters cubed on the bottom. So 250 over 150. And if I do this math, I'll do 1 times 250, so you multiply by the top, and then you divide by the bottom. If I do this math correctly, I will get a final pressure of 1.67 atmospheres. Now I didn't have the correct number of sig figs really, so let's just pretend I had 1.00 atmospheres. 1.00 atmospheres, so I have 3 sig figs, 3 sig figs, 3 sig figs. My answer will be in 3 sig figs. Did my pressure increase? Yes, my pressure increased. And my volume decreased. So if I need to show that particle diagram, I should show a volume that has large on the left and then a smaller volume on the right. So this is my 250 centimeters cubed at 1 atmosphere, and this is my 150 centimeters cubed at, which is now my 1.67 atmospheres. And how do I draw the particles? They're just closer together now. I'm probably bumping into each other more. So this, like this. I just drew 4 particles randomly. So I'll draw 4 particles that are closer to each other and probably bouncing off the walls. Okay? So this is how you would answer question number 1. In class, I showed you how to do question number 3, and I'm hoping you could use this template to help you answer question number 1, and then look at something like question number 2. If you have any other questions or would like another video, please comment on this video or send me a message in the remind.